Okay, so here I'm going to do a couple of examples of integration by substitution. So sometimes you've got a function that involves a product or a quotient, and because there are no product or quotient rules in integration like there are in differentiation, you've really got to be able to reduce the function down into individual terms, added or subtracted, that you can integrate individually. So let's have a look at an example of one of these. Let's take the integral of, let me see, okay, we'll take this one here. We're going to take the integral, and we're going to do definite integral here from 0 to, do 0 here properly, 0 to pi over 4. And we're going to look at e to the power of tan x, e to the power of tan x times sec squared x. And we're going to integrate this with respect to x, of course. Okay, so now in this case you've got two functions here. You've got this function here, this function here. They're multiplied, so we don't have a product rule. We're going to have to reduce this down some way, in some kind of format that we can integrate. So let's see how we're going to do that. We're going to do this by substitution. So in other words, we're going to take one of these functions and we're going to substitute them for, we're going to substitute it for u. So we're going to say, we're going to take this function here. Generally speaking, if you have a composite function, let's say a function f, let's say, and you had, that's a function of another function called g of x. So you've got a function here of a function. Generally what you do is you take this function here and you would let g of x here be equal to some letter, let's say u. And you would proceed from there. So really you would be looking at f of u here. So this would reduce to f of u rather than f of g of x. So this is the general idea of what we're going to do. So what we're going to do here is we're going to take the tan of x. So I'm going to say let u equal to tan of x. So instead of the tan of x here, I'm just going to put in u. That would give me du dx, if I was to differentiate this, du dx will just give me sec squared x. So that's kind of handy because I have a sec squared x here. So that would mean that du then, du, if I just cross multiply here, will be sec squared x dx rather. Sec squared x dx, and I have a sec squared x dx here. I can just call that du. And here I have e to the power of u. So really what I'll end up integrating is from 0 to pi over 4, e to the power of u du. So let's write that down. And just proceed from there then. So we're going to integrate, do this in white here, so we're going to integrate from 0 to pi over 4. Integrate from pi over 4. E to the power of, what was it, e to the power of u now, and we're going to have du here. So remember we had e to the power of, what was it, e to the power of tan x here, but u is now tan x, so we put a u up here. And then when you differentiate u, you get sec squared x, cross multiply here, you get sec squared x dx. So instead of the sec squared x dx here, I can just put in this here du. So now I can proceed with this relatively easily. So we're going to integrate e to the power of u. So if we integrate e to the power of u, we get just simply e to the power of u. Now that's just going to be then e to the power, we know that u is equal to tan of x, so that's e to the power of tan x. And remember we'll just put in our limits here as well. We're going to integrate between 0 and pi over 4. So let's just do that. That will give me e to the power of tan pi over 4 minus e to the power of tan 0. So tan of pi over 4 is just 1, so we just get e to the power of 1 minus, and the tan of 0 is can be 0, so we just end up with 0 here. So e to the power of 0 is just 1, so our answer here is just going to be e minus 1. So that's it, integrated by substitution. Let's just try another one. Okay, so just move this up a little bit. Try another example. So let's take, okay, so we'll go with this one. The integral from 0 to 6 of x over x plus 2 dx. Now this is a quotient here. We don't have a quotient rule like we do in differentiation, so I'm going to have to do some kind of substitution here. So what I'm going to do here is, I'll just do this in a different color here, so I'm going to let u again equal to x plus 2. So that will give me du dx. If I differentiate u, then here I'll just get 1. And then if I multiply across by dx here, I get du is equal to dx. du is equal to dx. Now, I also let u equal to x plus 2 here. That will mean, and I'll use this later on as well, if u is equal to x plus 2, that will give me x equal to u minus 2. Because I've got an x here on the top, so x is equal to u minus 2, so I can just put u minus 2 on the top here, and x plus 2 is equal to u, I can put u on the bottom here, and I know that dx is equal to du, so I can put a du here. So I'm changing all of these x's here to u's and du's. So let's proceed from here then. I'll just switch back to white here. So what I'm going to do here then is integrate this, so this is just going to be equal to the integral again from 0 to 6 of x here. Now we know that x is equal to u minus 2, so that's going to be on the top here, u minus 2. On the bottom here I've got an x plus 2. We know that x plus 2 is u, so I can put that on the bottom. And here I've got a dx, and we know that dx is du. Okay, so I can integrate this. It's still a quotient, but I can do it. Let's just rewrite it. So the integral then from 0 to 6. So I need to divide this u in here and the u in here. So that's just simply u and u is 1. And that's minus 2 times u to the power of minus 1. Remember, this is u to the power of 1. 1 over u to the power of, it's 1 over u to the power of 1 if you like. That's just u to the power of minus 1. And we have this 2 here as well. So, and we want to integrate that with respect to u. Okay, so let's do that. This we can do. We can integrate the 1, we can integrate this here as well. So let's do that. Okay, so when we integrate this, then we get, if you integrate 1 with respect to u, that will just give me u. And then that's minus, we have 2u to the power of minus 1, or 1 over u. If you integrate 1 over u, you get log of u, modulus of u here actually. Okay, so that's it there. So we want to put in our limits then as well from 0 to 6. Okay, now let's just do this. Okay, so let's work through this area. Okay, so let me just flip these back again as well while I'm at it. So really our u, remember, if we go back up here again, our u is x plus 2, so I'm going to put that in as well here. So we're going to put in x plus 2 here, minus 2 times log the base e of the modulus of x plus 2, and we're going to integrate that between 0 and 6 here. Okay, so let's proceed with this one. So that will give me then, we want to put 6 in here, so if I put 6 in here, I'll get 8. Just put this here, this is 8, 6 plus 2 is 8, minus 2 log the base e of 6 plus 2, 8 as well. And I want to subtract. So now I'm going to put 0 in here, so that will give me 2 minus 2 log to the base e of 2. Okay, so let's do this then. We will get 8 minus 2 log 8 to the base e. So let's just take away these brackets first and see what happens. Let's see, 8 minus 2 log 8 to the base e minus 2, this is minus, this will become plus here, 2 log 2 to the base e. Okay, so now we can just simplify this. We've got an 8 minus 2 there, which is 6. We've got minus 2 log 8 to the base e plus 2 log 2 to the base e. I think what I might do here is just factorize these. So let's see, we'll take minus 2 out here. That will give me log 8 to the base e. And then because this is plus and I've got a minus out here, this is going to have to be a minus here. Minus minus will give me this plus here. So that's log of 2 to the base e. Okay, so how do we proceed from here? Well, you can see here by the laws of logs you can do these two here. Let's see, this is 6 minus 2. Now because we are subtracting 2 logs here to the base e, you divide the 8 by the 2 if you remember your laws of logs. So this is just simply the log to the base e, 8 divided by 2, which is 4. So let's see what we can do here. Oh yeah, okay, so we can take the 6 and we can take this 2 here. We'll just take the 2. And again, another law of logs here, we can take this 2 and just stick it up here as a power of 4. So I'm going to take out a log to the base e of 4 squared, which is 16. And that's it really, that's the answer. And that's really it for integration using substitution.